So we're looking at numbers 13 through 16 here, and starting with number 13, which says a researcher wishes to determine whether the rate of water flow in liters per second over an experimental soil bed can be used to predict the amount of soil washed away in kilograms. The researcher measures the amount of soil washed away for various flow rates, and from these data calculates the LSRL line to be amount of soil eroded equals 0.4 plus 1.3x times flow rate. What can you determine about correlation between amount of eroded soil and flow rate? From this line, we can't determine a value for correlation. That's just not possible from an LSRL here in this case. So that immediately gets rid of A and B. C says correlation is positive, but we cannot say what the exact value is. This one is correct because the slope of the LSRL is positive. And remember, the LSRL is measuring is a line that represents the relationship between two variables. And so if the slope of that relationship or that association is positive, that means that the correlation is positive. D, either positive or negative. It is impossible to say anything about the correlation from the information given. This is not true because we know that if the slope of the LSRL is positive, then the correlation is also positive. 14 is the graph above plots the gas mileage of various 1978 model cars versus the weight of these cars in thousands of pounds. In the graph, the points denoted by the plotting symbol X correspond to cars made in Japan. From this plot, we may conclude that, so here's the plot, we'll look at that really quickly. Okay, and then it says, A, in 1978, there was little difference between Japanese cars and cars made in other countries. So for the most part, this is correct because most of the points here are along a similar. They all take the same or similar linear shape. But there are a few differences, and so we're gonna that one might be correct, but we'll check back. B says in 1978, Japanese cars tended to be lighter in weight than other cars. So over here you can see that the X's, which denote the Japanese cars, they're mostly towards the left side of this plot, which shows that they have a lower weight. So that trend is actually true. None of the Japanese cars exceed 3,000 pounds, while there are plenty of cars not made in Japan that exceed this weight. So that one is true. And then C says in 1978, Japanese cars tended to get poorer gas mileage than other cars. This one is untrue because for the most part, the Japanese cars are ranking on the higher side of MPG here. So C is incorrect. D says the plot is invalid. A scatter plot is used to represent quantitative variables, and the country that makes a car is a qualitative variable. This one is not correct because this scatter plot does measure quantitative variables. It measures the weight and the miles per gallon of a car plotted against each other. Those are both quantitative variables. It actually does not plot the country that the car is made. It only denotes it through the use of the X's. So here B is correct because it makes a lot more sense than B. Than A. It's really completely correct while A is slightly correct. 15, it says skip, but we can look at this plot anyway, and that's what concave up looks like. It's decreasing in concave up. I think that's a calculus problem that is on this for some reason. 16, which of the following be necessary to establish a cause and effect relation between two variables? So here it says A says a strong association between the variables. That's necessary for a cause and effect relationship for sure. B, an association between the variables observed in many different settings. This is true, yes. And then C says plausibility of the alleged cause. Yes, you also do need that. So yeah, I think the answer is D here. All of the above. Every one of these choices makes sense for a cause and effect relationship between the two variables. So that's it. That's 13 through 16. 15 we skipped because I think it's a calculus problem. And yeah, that's it.